Morning class 10th. Now in this lecture we will learn electron gain enthalpy. So we will start electron gain enthalpy topic from the definition. So for example, this is the nucleus of any atom and these are the shells. So the electron gain enthalpy is the energy released or liberated when any upcoming electron is accommodating in the valence shell of any particular atom. Then this an amount of the energy that is liberating is known as electron gain enthalpy. Means electron is coming and take the portion in the valence shell, and then the energy will be removed. So this removed energy, this liberating energy, is known as electron gain enthalpy. So again we can define the definition that when the electron gain enthalpy is the energy liberated when any upcoming electron is trapped or the electron is accommodating in the valence shell of any gaseous isolated neutral atom to form the corresponding anion. If the electron will be accommodated in the valence shell of any neutral atom, then that particular atom will be changed into anion. For example, if we will take the example of chlorine, so atomic number is 17, so 28,7. So if the chlorine atom will accept one electron, so it will change into Cl minus 1. So initially the configuration will be 28,7 and now the configuration is 288. So now the octet is completed, and after gaining one electron, this chlorine neutral atom will remove energy in the form of heat, and this energy will be equal to electron gain enthalpy. So electron is coming, electron is accommodating in the valence shell of any neutral gaseous isolated atom to form the anion, and then the energy will be removed, and this energy will be equal to electron gain enthalpy. Electron is coming and energy is liberating, so this energy will be equal to electron gain enthalpy. Now we will discuss the trends of electron gain enthalpy, or we can say that electron affinity. They both are same thing, electron gain enthalpy or electron affinity. So when one move from top to bottom in any particular group, for example this is 17A group, fluorine, chlorine, bromine, iodine, acetylene. The configuration will be 2,7, 287 and so on, and top to bottom shell number increases. That's why atomic size increases, or we can say that nuclear pull decreases. So if the nuclear pull decreases, electron gain enthalpy decreases. Why? Because for accommodating electron in the valence shell of any gaseous isolated neutral atom, there should be some attracting force to hold electron, or to attract the electron there should be high nuclear pull, so that electron can be trapped in the valence shell of any neutral isolated gaseous atom. So if the atomic size decreases, or we can say that nuclear pull increases, then electron gain enthalpy will increase. So we can say that electron gain enthalpy is directly proportional to nuclear pull and inversely proportional to atomic size. So top to bottom in any group, the electron gain enthalpy decreases. Why? Because nuclear pull decreases, or we can say that atomic size increases. But so according to this concept, the order should be like that: fluorine highest electron gain enthalpy, then chlorine, then bromine, then iodine, and then acetylene. Or we can include these four elements, especially fluorine, chlorine, bromine, iodine. But the order in reality the order will be like that. Means the chlorine got the first portion, chlorine, fluorine, bromine, iodine. Means in reality the order will be as this: the electron gain enthalpy of chlorine will be high as compared to fluorine. So why there is some exception for the electron gain enthalpy for chlorine and fluorine? And according to the concept we have already learned that if the nuclear pull increases, then electron gain enthalpy decreases. If the nuclear pull decreases, then electron gain enthalpy decreases. So there's some issue about electron gain enthalpy. Even we have completed the electronegativity. So in electronegativity, top to bottom electronegativity decreases because nuclear pull decreases. But in the case of electron gain enthalpy, there's some issue for the portion of fluorine and chlorine. Chlorine has the high value for electron gain enthalpy as compared to fluorine. So the reason is that for example, this is the diagram for fluorine and chlorine. So for for fluorine there are the two shells, and for chlorine there are the three shell, 1 2 3. So in spite of having high nuclear pull, because there are the two shells, so the steps are less, and this side steps are 4 3, means the shell number is more, so the size will be large in the case of chlorine. And chlorine has the smaller size as compared to chlorine. So in the case of fluorine, in spite of having the high nuclear pull, it has a low value for electron gain enthalpy. The problem is that, and in spite of having a higher atomic size, a large atomic size, or we can say that the low value for nuclear pull, it has high value for electron gain enthalpy as compared to fluorine. So what is the reason behind that? So firstly, electron gain enthalpy, it's about accommodation, not about the attracting the electron only. We have already completed in electronegativity session that if the nuclear pull increases, electronegativity also increases. But in the case of electron gain enthalpy, the electron is entering and the energy will be removed. The energy is liberating. So it depends upon the size of the shell as well. So while entering the electron in any particular shell, electron should feel stability. So the size of the fluorine atom is very less, because these elements are when one move from left to right. So we know that in rightmost element they have the low atomic sizes, because the nuclear pull is so high. So that is the reason that all these elements, they have the lowest atomic sizes as compared to the former element. So below the atomic size, we can simply, in simple terms, we can say that the L shell of fluorine, the size of the L shell of the fluorine is very small and very congested to add any extra electron. And in the case of chlorine atom, the size of M shell is proper to accommodate one extra electron. So it is not only about attracting the electron, it's about the accommodation of the electron. If the electron feels stability while entering in the valence shell, so it will be easy for electron, and the maximum amount of energy will be removed. So we can say that in the case of fluorine, the L shell has the size of the L shell is small. That's why the upcoming electron feels inter-electronic repulsion, and that is the main reason the electron gain enthalpy of fluorine will be less as compared to chlorine. And in spite of having high nuclear pull value, still it has the low electron gain enthalpy value as compared to chlorine. So the order will be, in first number chlorine, and then fluorine, then bromine, then iodine, and then astatine. Even we can ignore astatine, so these four are important. So first number chlorine, second number fluorine, third bromine, and then fourth iodine. Then same to same concept, top to bottom electron gain enthalpy decreases because nuclear pull decreases. And if we discuss in the case of period, so it is very simple. When one move from top to bottom, left to right in any particular period, atomic size decreases, or we can say that nuclear pull increases, so electron gain enthalpy increases. Because we have already I have already shown this terms that electron gain enthalpy is directly proportional to nuclear pull, and it is inversely proportional to atomic size. Okay, but in the case of neon, we cannot say that it has the high value for electron gain enthalpy. Same to same, it is very rare gas, octet is already completed according to 10 2,8, so it does not have any affinity for the electron, so the value will be almost zero. It does not have any affinity for the electron, for achieving the electron, due to the inert nature, because octet is completed. So from this left to right, atomic size decreases or nuclear pull increases. That's why we can say that electron gain enthalpy increases. So these are the topics and these are the concept for the electron gain enthalpy. So top to bottom it will decrease and left to right it will increase, but there's some issue about the exceptional case for fluorine, so you should remember this condition. Okay, thank you so much.